All right, guys, welcome back to my channel. My name is Oluwaseun, and today we want to talk about the EKS Auto Mode. The EKS Auto Mode. We're going to be talking about the benefits of the EKS Auto Mode. We're going to be looking at some of the advantages. We're going to be looking at a shared responsibility model together. And we're also going to be setting it up, leveraging Terraform. All right. And then we'll deploy an application onto it. We'll look at how you would deploy an Ingress controller in EKS Auto Mode, how you can deploy a storage class in EKS Auto Mode, all right, as well. But before we get into the deployment, into the Terraform configuration and all of that, let us understand what problem does the EKS Auto Mode solve? What does it solve for us? And there's no better way to explain that than by looking at the shared responsibility model. Now, of course, you can get a shared responsibility model from this link. If you scroll all the way down, you would see the shared responsibility model right here. Now, if you look at the shared responsibility model, now on the right side, you have the shared responsibility model with EKS previously, which basically looks more like a 50-50 thing. So which means AWS is taking care of 50% of, the responsibility. And as the customer, you're also responsible for 50% of the, whole cluster management and all. So if you look at the shared responsibility model for the EKS previously, AWS is basically going to manage the global infrastructure, like the region, the local zones, the edge locations. Foundational services like compute, storage, networking, monitoring is also managed by AWS. And then you have the cluster control plane, which is the API server, the XENIs, the etcd database. All of that is managed for us by AWS. And then as customers, we manage the cluster capability, auto scaling, pod networking, which something like, pod auto scaling, all those kind of things, node auto scaling, the load balancer, the storage drivers, the health and repair, the lifecycle operating system, the patching, the VPC infrastructure, the add-ons, the application container, the availability of it, the security of it, and the monitoring of those applications. So that is our own responsibility as customers. But then if you look at the EKS Auto Mode to my left, all right, the EKS Auto Mode, AWS is taking more of the responsibility of us, and then as customers, we have less to worry about. And so if you look at the shared responsibility model for the EKS Auto Mode, you would realize that about 70% of the responsibility now lies on AWS, while you as the customer, you have just about 30% of the responsibility to take care of. So let's take a look at what we have. So AWS, again, they will manage the global infrastructure. They will manage the foundation services. They will also manage the EKS control plane for us, which is the API server, etcd, the ANIs and all. And the cluster capability that was previously managed by the customer, AWS is taking that responsibility now, which means they will manage compute auto scaling. That means you won't have to necessarily install the carpenter, all right, into your cluster to help you manage your node auto scaling and all those kind of things. So which means you might not need something like a managed node group. Now, pay attention to what I said. You might not need something like a managed node group, which means AWS by default, by the time you set up your cluster with the EKS Auto Mode, by default, they will have Carpenter running already to help you manage your node and things like that. So which means at the first instance, when you set up your EKS Auto Node, it might not have any node, because the idea behind the Auto Mode is to help you reduce cost as much as possible, right? Which means you only have nodes running when there is a workload that has been deployed into the cluster. Does that make any sense? Which means if you don't have any workload running in the cluster, there's no point you having nodes running without any workload. All right. So with the cluster capability like auto scaling, AWS is taking care of that. Pod networking, network policies, load balancing, storage drivers, that has now become the responsibility of AWS. Now, they moved it a bit higher. For example, the cluster EC2 instances, the lifecycle, operating system, patching, monitoring, the health and the repair of those EC2 instances that will be managed by Carpenter is now the responsibility of AWS. Okay, now the only thing that you and I as customers get to manage is now the VPC infrastructure, the add-ons, the application containers, the availability of it, the security of it, and the monitoring. That means we really do not have to worry about infrastructure as much anymore. Right? The reason I said as much is because we still have to manage our networking, which is the VPC side of things. But in terms of your nodes, your worker nodes, the control plane, the API server, auto scaling, storage, all those kind of things, you don't need to worry much about those things anymore. So that is the benefit of the EKS Auto Mode. So you can see that with the EKS Auto Mode, AWS is taking 70% of the responsibility, and you are left with 30%. That means you have more time to worry about your application. You have more time to worry about the security of your application, the monitoring of your application, which means you can have more time on your hand to instrument your code, to get more visibility into your application and all those kind of things. Instead of worrying about scaling your nodes, operating system patches, security of the operating system, monitoring of the operating system, all those kind of things, AWS is saying, don't worry, we got that. You just focus on the life cycle, the availability, the security, the monitoring of your application that runs within the cluster. And that is the promise that AWS has given us as customers. Okay, so now having helped us to understand the benefit of the EKS Auto Mode, now let's just take a look at the documentation, right? This is the documentation right here. If you scroll all up, you can see the EKS Auto Mode here, and then it gives you, all the things that you need to understand about the EKS Auto Mode, how to deploy it, how to set it up, how to run your applications, Ingress controller, storage drivers, anything you could think of is actually all right on this particular documentation page. So if you come here, you can see create a cluster. So they give us 3 different methods by which we can actually create a cluster. So the first one is the EKS CTL, which leverages CloudFormation behind the scene. The other one is the CLI, AWS CLI, and of course you can go through the management console to do that. Now, what we are doing is that we want to use Terraform to deploy our own EKS Auto Mode because it's faster and it's easier for us to manage, right? And of course, Terraform, it's an IC tool, right, that everybody is familiar with, and it has, it's a common platform that we can all, be familiar with. And all EKS CTL is also very good, right? It has its own, niche or his own use case, the way you want to use it. All right, but for the purpose of this video, we are going to be using Terraform to deploy the EKS Auto Mode. So this documentation page, which of course will be available in the README of the repo, all right, you can go through it and understand, whatever it is that you want to run. For example, if you click on the configure, you can see the node class, the node pool, and all that, the Ingress class, the service. So everything that you need is actually here. All you need to do is to go through it and then get an understanding of what has changed and what AWS is allowing going forward. All right, for example, the way we used to deploy Ingress has changed, which I'm going to show us, right? Because now, initially when you want to deploy your application load balancer controller, you have to do that through add-ons or through Helm, right? But by default, the load balancer controller is kind of part of the whole EKS Auto Mode. So you don't need to go to Artifact Hub to download the controller, to do the configuration and all again. All you need to do is, to just tag your subnet, right? You still need to tag your subnet. For example, you need to tag your public subnet with this. You need to tag your private subnet with this if you want to leverage, Ingress controller or the AWS load balancer controller within your cluster. Okay, but you installing the controller yourself, that is part of what AWS has taken care of. The same thing also happens with storage. All right, you don't have to install the controllers and all those kind of things. Just install the components, 1 or 2 components, and you're good to go. All right, so we're going to see all of that in today's video. So Having said all of this, let's get right into the Terraform configuration. I'm going to walk you through it, and then we deploy our EKS Auto Mode. So first of all, let's explore the Terraform registry, right? So I'm going to click on Terraform registry. That will take us to the Terraform registry page, and I'm going to click on Browse Provider. And right here, I'm going to search for EKS. I use the EKS module, all right, to just speed things up. So if you come here to the modules, you'll see the EKS modules right here. And of course, the latest version is 21.80. And of course, the first thing you want to check, if you're using any module, all right, if you're using any module at all, the first thing you want to check is to check the dependencies. And the reason why you want to check the dependencies is because you want to know what are the other providers or modules that this module depends upon. So we're using the EKS module. The EKS module has a provider dependency as well. For example, it requires the AWS, all right, HashiCorp, 6.15 greater than 6.15, HashiCorp Cloud Init 2.0, Null 3.0, Time 0.9, and then TLS 4.0. All right, so you need to check the dependencies. And of course, if you go to the README as well, you would see different examples, okay? So EKS Auto Mode, you can see the examples, all right here. And of course, we're going to be using some of these examples, right? And of course, as we know, the version of Kubernetes that we have now is 1.34, and that is what we're going to be using as well, okay? 1.34. And of course, we still have the managed notebook example right here. And if you scroll all the way down, you would see you're going to see the resources and you're going to see the inputs. So the inputs are basically things that you can add when you want to create your EKS cluster. So these are additional inputs that can be added, all right, when creating a cluster, okay? You can use, of course, you're going to use some of them, but it's not that you have to use all of them. At the end of the day, the inputs you're going to use in your Terraform configuration depends on what you're trying to create, all right, what your intentions are, what you want to do, and all of those kind of things, okay? So now, let's get into the Terraform configuration. So here, I basically just have two modules. I have the EKS and then I have network. So if you go to the EKS, for example, this is the EKS module that I'm using, all right? And you can see here, I'm using the 21.0. The name, the cluster version, the endpoint is true, enable cluster create admin permission true, and then cluster compute config. Compute config basically means you want a notebook that is general purpose, right? Notebook that is okay for, general workloads, nothing much, nothing heavy, just, general applications and all. But of course, you can always change, that. Then the VPC, the subnet, create node security group, true. Create security group for the cluster node, true as well. Because I wanted to create all of the security groups, all the ports that needs to be opened up, should be opened up and should be properly configured, all right, as well. And then you have some tags here. Now, really, this carpenter tag is not necessary because when I went through the documentation, I didn't really see anywhere where it mentions, the carpenter tag and all this kind of things, but I just added it from a previous configuration that I have already used before. So I just thought of just leave that as is. The tag that I feel is more important is actually has to do with the subnet tags. All right, that is very important because without a subnet tags, if you don't do it properly, it means that you will not be able to, use the load balancer controller within your cluster. All right, so that's one is the one that I feel that is very important as well. All right, so you can see under the locals, I don't have anything much under locals. So you just have the main, you have the output, you have the provider, which again, the provider here, I don't think is necessary, but it was just, something from a previous video that I've done, and all that. I just felt like I just leave that, but I don't think this particular one here is necessary because I am not authenticating into the cluster to do anything or to install anything or to enable anything, right? The purpose of this provider in the earlier video was basically that you want to use the EKS, add-ons, right? Where you want to install Prometheus, you want to install the load balancer controller. That is actually where this was needed. But I don't need it now, but I just still felt I should leave it as is. And for the network, like I said, for the network, you only need just about 2 tags. The public subnet tag, which will be Kubernetes.io that we saw earlier. And then this one is for the internal ELB, which is the private subnet tags. And that's pretty much, all right, all that you need. All right. So today it's about the auto mode. So I won't go deep into the modules, the network and all. I believe I've talked about, them in some videos that I've done all right before. But of course, before you set up an EKS cluster, networking is important, VPC is important. So that is why we have the network module here to set up, all right, our VPC side of things for us, because we don't want to deploy it on an already existing VPC. We want to create all of that by ourselves, all right? And of course, you have your main. So here, the main here is where I'm calling the module, all right? So this is where I'm calling them, both the EKS and of course the network. And of course, I have a few output here that will be printed out, all right, for me. Okay, so without wasting much of our time, okay, so let's just go ahead and deploy this. Let's run the Terraform apply, let this run, and then we begin to explore the EKS Auto Mode. Let's see, after we have deployed it, what was installed, what was not installed, how do we install the Ingress controller, how do we go about the storage, the EBS CSI driver, all those kind of things. That is really what I want us to see in today's, all right, video. So I'm going to basically export my credential very quickly. Okay, so we have that, and then I'm going to do Terraform FMT recursive just in case any of the file has moved. So just rearrange them properly. And of course, you want to do your Terraform validate. All right, and you want to do Terraform plan. All right, so you're planning out into and saving the plan into a TA plan so that applies becomes easier. When you do Terraform plan out into a plan file, it becomes easy to apply, because when you do Terraform apply, it won't go through the plan phase again. You basically just take the file and then apply whatever it is has been saved in the file. So here, do Terraform apply TF plan. All right, so that would take the plan file and then of course create all the things that are needed to be created. Okay, so this is going to take some time, not too much time, but it's going to take some time. So once this is done, we'll come back, all right, and then get into the EKS Auto Mode, configuration and all of those kind of things. That is which is actually the purpose of today's video. All right, so let's just wait. Let's allow this to run, and then we'll come back once this is done. All right, so now we have the EKS cluster deployed. As you can see, we have it deployed. It didn't take much time, all right? So let's, connect to the cluster and see what we have, right? So to connect, we know it's EKS, AWS EKS update, kubeconfig. So we need a cluster name, all right, which is these, or perhaps we can try the region first. The region is EU Rest2, and the name is this. Okay, so that is also connecting to the cluster. And then if you do kubectl get node, right, you would see here that we don't have any node at all, which means we have a cluster that we have created and does not have a node at all. And if you want to confirm that doubt further, you can actually come over to the console, all right, and then you can do EKS. All right, you can go to the EKS page, and then if you come right here, you will see that if you come under compute, you will see that we have 0 node. The only thing that we have is just the node pool, which is general purpose, but we don't have any node at all. All right, we don't have any node at all. Okay, so that basically attests to, what we said earlier, that the EKS Auto Mode is about, cost optimization. Okay, that you only get a node running, when you have a workload that needs to be deployed. Okay, so that is basically to buttress the reason why we don't have any node at all. Okay, of course, if we do kubectl get ns, of course, we have a few namespaces, the kube system, the kube public, the kube node list, those ones are there, right? And of course, even if you do kubectl get port -a, I mean, we don't even have any port at all, right? So which means the only thing we have running is just a control plane. All right. So it is when there is a workload that the node gets created and the services that are necessary, that are needed, get installed, all right, on the node. As it is now, we don't even have any add-ons, right, installed. Metric server, all those kind of things, we don't even have them installed. Okay. So basically, the idea here is that what you need, you install. What you don't need, you take it out. So that way, you save cost, and then you don't run things that are not necessary or that you don't need within your cluster that cost you money. So we save that money to run the workload that we need or the services that we actually, all right, need. Okay, so let's do some tests. So here I have this test deployment. All right, and I'm going to say that, let's say we want 10 replicas, right? This is just Nginx, just a test, okay? So now if I do kubectl apply, all right, and then I run the test deployment. Now the test deployment is going to run, and automatically that would trigger, all right, the EKS to say, hey, there's a workload, and that means there is a node to be created. So if I do kubectl get port, all right, so now I would see that I have 10 ports that have been scheduled pending, right? And then if I check that again, I should see that it's still in a pending state because it is trying to create, all right, the node that it is that is needed. So if I refresh this page, I can see now, look at that. All right, a port is automatically created, C6A large, and the compute is what? Auto mode. Can you see that? So it responded to that workload. So if I remove all of these, or if I scale the workload down to 0, it means that the instance is also going to be deleted. So that means if I have a workload that requires one instance, you only get one instance. If I have a workload that requires 2 instances, you get 2 instances. And then if you don't have any workload that is running at all, you don't get any, all right, instance or node created. All right. So that's the whole idea behind the auto mode. It saves you cost, all right. Nodes are provisioned on demand. That's the whole idea. Nodes are provisioned on demand. Unlike before where you have node groups, so whether you have a workload running or you don't have any workload running, the node groups are there, all right, accruing cost. But right now, the idea is nodes will be created in response to workload demand. That is the idea behind the old EKS, all right, auto mode. Okay, so if I come back here now to say kubectl get port, I should see that I have all my pods running. Can you see that? All the ports are running. So now if I come back right here and I turn this back to 0 and I apply the same file again, of course, that will scale down, and that means all the ports will be deleted. So if I do kubectl get ports, I shouldn't have any ports at all. And that means if I do kubectl get node, all right, or nodes, okay, I should see that yes, the node is still there, but after some time, it is going to be terminated or shut down. So if I come here to EC2, for example, if I come to EC2, of course, I'm going to see the node right there. If you go to instances, you'll see that the instance is running. But after some time, of course, it's going to be terminated. All right. So that is one thing about the EKS, all right, auto mode. So workload, all right, nodes rather, is provisioned in response to workload demands. Okay, so that's the whole idea. So now let's just deploy, let's look at a few other things that I wanted to show us. Now, initially, when you want to, when you have an application that is running and you want to expose it via Ingress controller, right? What you do basically is that you have to install the load balancer controller or the Nginx Ingress controller and all those kind of things. But in the auto mode that we're using now, you don't need to install the controller because in a way, the AWS load balancer controller is already part of the whole setup. So what you need are basically 3 files, or let me say 2 files. And if you go through the documentation, let me just refresh this and see. Can you see? Terminated because there's no workload. So what am I doing with the instance? It's terminated. So that's the advantage of the auto mode. All right. So now let's take a look at this documentation. Okay. So if I want to create if I want to deploy an application and I want to expose the application via via Ingress, right? What do I need to have installed? All right, what do I need to have installed? So I'm going to take you through that, and then we'll see. So when you want to deploy an Ingress, right, resource, you need a controller. But when it comes to the auto mode, we don't need to install the controller again because remember, from the shared responsibility model, compute auto scaling, load balancing, and all those kind of things has been taken care of by AWS. So which means I don't have to go through the stress of installing the controller and making sure that the controller is installed and is working and all that. AWS has somehow managed that for me behind the scene. But there are still some components I need to install into the cluster to leverage, all right, the load balancing controller and other component or services that AWS has installed as part of the EKS Auto Mode. Okay, so if I want to use the Ingress, what do I do? Now, if you come here to configure, you will see create Ingress class, right? Now, if you click on this create Ingress class and you scroll down, right, it tells you, if you look at under the overview, it says the first thing you need to do is to create a workload, which means you must have your deployment, your the service and everything is running, and then you create an IngressClass parameters, right? A resource that will specify the values such as the certificate you intend to use, the subnet, and those kind of things. And then you create an IngressClass resource that will specify the EKS Auto Mode, the controller resource, and all of that. And then the Ingress resource, which basically will associate the HTTP paths and port to the cluster workload. So the first thing is that you deploy your workload. The next thing is that you deploy the IngressClass parameters, and then you do the IngressClass, and of course your Ingress resource. If you scroll down here, you can see an example of the workload. So this is an example of the workload, a deployment that would just basically a simple deployment. And then the IngressClass parameter, this is a very minimal, IngressClass parameters that they've given us here. And then of course, as you're creating those things, you apply them. And then the IngressClass. So for the IngressClass, you have things like, the controller. This is where you specify the controller. All right, that you want to use ALB because, of course, you might decide you want to use NLB, right? But for this is ALB. So this is where you specify the controller configuration and, of course, the parameters. And, of course, the parameters should reference, your IngressClassParams, which is the one that we have created right here, okay? And then after you've done that, then you can now create an Ingress resource that basically would help you to connect, the path and the port to the workload running inside of the cluster, right? So those are the 3 things that you need, okay? So let's take a look at how we can actually achieve that as well. So here, in my Kubernetes folder here, I have a simple application that I put together, a contact form application, right, that I just want us to use to test to test the Ingress, controller and how it works in the EKS, Auto Mode. So first things first, of course, I can apply all of the things that I have here one by one. All at once, but then let's do it one by one, right? So kubectl, first of all, I can do cd and, get into the Kubernetes folder. And then I can do kubectl apply -f. So I can do configure the YAML. I need to deploy the secret, the YAML. The purpose of the video is not about the workload. It's about, the changes as regards how you can deploy an ingress, storage drivers, and all those kind of things. Okay, so I won't be going over, right, the config map, the secret, and all those kind of things. So the purpose of this video is to just demonstrate to us things that have changed as touching ingress, as touching storage driver, the EBS CSI driver, and things like that. Okay, so that's the purpose of this video. So let's deploy this. kubectl apply -f. All right, so I guess it was expecting a single argument, so that's fine. So let's deploy that. And the next thing we're going to do after this will be to deploy the secret component. That'll be the next thing to do, all right, after this. Okay, so that's been deployed. So we can also deploy secret as well. All right, so let's do that. Okay, good. So now let's deploy the application itself. Okay, so the application is this PHP deployment and PHP service, both of them. All right, so let's do kubectl apply -f PHP app deployment. So let's deploy that. Okay, so let's deploy the service as well. Okay, good. All right, so now we have the application deployed. All right, the PHP application, we have it deployed and all those kind of things. And then we can do the database application as well, right? We need a database to store information and all of this, all those kind of things. So we're going to do kubectl apply for database. Like I said, the video is not about, database and all. It's just for us to see, what has changed in terms of Ingress controller, storage driver in EKS Auto Mode. All right. So my SQL DB deployment. So let's run that. And once that is done, we'll do for service as well. Okay. All right. So let's do the PHP admin as well. So because we're going to need all of that. PHP admin deployment, and then we do for the service also. All right, so we do for the service as well. So now that we have all the application installed, so we can do kubectl get port. All right, so we can see that MySQL deployed is still in dependent state. The PHP application has been deployed. The PHP admin application has been deployed. The database is still in dependent state, but right, I mean, after some time, it's going to get into the running state. All right, so we can be sure about that. So now, this right here is my IngressParams. So if you look at what I have here, right, the version here is EKS AmazonAWS.com version 1. And of course, if you look at what we have here in the documentation, it's basically the same thing, right? So if you look at it here, and this is the first thing that we need to deploy. So let's run through what we have. So the kind here is IngressClassParams, as we see in the documentation. The metadata is ALB, the spec now, the schema. So here is where you define your schema. Initially, if you watched some of my previous videos, initially, you actually would define your schema right here. All right, in the Ingress resource, this is where you define your schema. But you can see that now we have, less annotations. Because in the previous EKS, all right, that we usually deploy, we'll have a lot of annotations where we define the certificate, the schema, the group, and all those kind of things. But what they've done now is to divide all of that into 2 or 3 different files. So in the params, that is where you define the schema. You define the IP address type, whether it's going to be draw stack or it's going to be IPv4. And this is also where you define the group. The group here basically means that you want this, maybe you want a particular deployment or application to use a particular load balancer, right? So maybe every application in your dev environment, for example, you can say, okay, every application in my dev environment, I wanted to use the same load balancer. So you create a group and then put every one of them in that group. So every application you deploy in the dev environment can use a single load balancer all right, for exposing, their front end or their application. And this is also where you define the certificate ARNs as well, because you can actually have more than one ARN. So this is where you define the ARNs. But here, I'm using just one ARN, okay? And then, of course, if you have any tagging, this is also where you define your tags. And here, the tag is a key value pair, which means you have a key, you have a value. You have a key, you have a value. So that's how it is defined. And then the load balancer attribute as well. I mean, the timeouts and all those kind of things, the routing, HTTP2 enabled and all that. This is where you define some of them. Now, these parts are not really necessary, but of course, I just included them for you to see other options that are obtainable. All right. So this is the first file that you want to deploy. Okay. And after you have deployed this, then you now deploy your IngressClass. So if you look at the IngressClass does not contain so much, all right, of data and all of that. The only thing that is significant here is on line 8 where you have the controller. So the IngressClass is what you use to define the controller. Okay, this is the controller that I want to use. So the parameters is basically used for you to set up the parameters like the schema, the IP address, the group, the certificate, and all of that, right? But the IngressClass is where you define this is the controller that I want to use. Remember, the controller has been installed. You're basically just instructing the controller that the auto mode has installed to say, this is the controller or this is the load balancer that I want you to create on the console for me that I want to use. And that's pretty much it. And then you have the API group and the class, and then of course the name. Now, remember, the name you have defined here must match what you also have here in the metadata. Okay, because that name is also a way to also group some of these things, right? And then, of course, you now have your ingress resource, which is a third component based on the documentation that we just read. So in the ingress resource, you define your kind as ingress, your metadata still remain the same. And then here you have fewer annotations. So the only annotation we have here is just 3 annotations: the target type, the path, and the SSL redirect. Right? That is what we have here. And then, of course, you define your rules. Okay? So that is what you have. So you can see that we have, instead of putting everything in just a single file called Ingress, now you have the IngressClass parameters, you have the IngressClass where you define a controller, and then you have the Ingress file where you define, all right, the mapping, the HTTP and the port mapping and all of that. All right? So having explained that, now we can actually go ahead and deploy we can actually go ahead and deploy the Ingress. But hold on, the SQL is still pending. Now, why is the SQL pending? I mean, why is it not running? Now, the reason why it's not running is this, all right? Because, I tested all of these things before I started recording, so I knew exactly why it's not running. So now, if you look at the database, for the database, I actually defined a volume mount here. So the database is not running here because I have not created the driver, right? So it's not running. I've not created, right, the storage class, I meant to say. All right. So here you have the volume mount that I defined, and the name of the volume mount is this, and there's the path that I want to map it to in the container, and the volume name, the persistent volume claim. So I've not created this persistent volume claim. And in EKS Auto Mode, even though based on the documentation and based on the shared responsibility model, storage driver are also being taken care of, but you still have to create the storage class yourself. Because if you look at what the documentation, it says EKS Auto Mode does not create a storage class for you. You must create a storage class referencing this particular provider to use the storage capabilities of EKS Auto Mode. Okay, so here I have mounted a PVC, but I've not created a storage class. So that is why you see here that the MySQL database is still in the pending state, because it is still what? Expecting this PVC to be created, right? And of course, like we saw in that documentation, we must create a storage class first. So if you come back here quickly, this is the storage class. And of course, you can see the documentation right here. All right, so you can literally just copy what you have here and use that to create your storage class. So what you have here is this storage class, the EBS CSI, and then of course you have the annotations, you have the provisioner, and then the type, the encrypted, and all those kind of things. So in order for this MySQL port to be in the running state, that means I need to do kubectl apply, all right, and then EBS, I need to create the storage class first. And once the storage class has been created, I need to come here to the PVC to create a persistent volume claim that my database actually needs, all right, to be in the running state, okay? So I need to do kubectl apply, all right, PVC, so I need to create that. So once that is created, if I do kubectl get port now, right, my database should in no time be in the running state. All right. And of course, if you go to the console, you will see the volume that we have created. So the volume we created here is 10 gig. So if I go to the console, for example, if I come here to volumes, all right, I should see a volume that has been created. So you can see, look at the volume here, right? It's Sandbox Cluster Dynamic PVC, and you can see it is what? 10 gigabyte. So if I come here now and I do kubectl, all right, get SC, which is storage class, all right, I can see the storage class here, and I can see here that it's been created, right? You can see. And of course, if I do kubectl get PVC, all right, so I can see the PVC right here. So you can see that here it says bound, which means it's been created and it's been associated with my database, right? And if you look at the volume ID, you can see here, this is 4330. So if I come here, right here, you can see here, 433, all right, 0. Is that okay now? So I didn't have to install any, controller, driver, all those kind of things, just the storage class, right? So if I do kubectl get port again, I believe that the SQL database should now be in the running state. Can you see that? It is now in the running state. So I've used that to explain to us the storage part of things, right? So let's go back to the Ingress controller. So first of all, we need to do kubectl apply, ALB Ingress, all right, ClassParams, that's the first thing we want to install. So we press enter. All right, so the next thing is to do kubectl, all right, class, the YAML. So we install the IngressClass, which is responsible for setting up the controller and all those kind of things for us. Okay, and then of course we apply the Ingress resource now itself. So we do kubectl, right? And then we do that. So once that is done, that would create a load balancer for us, do the association and everything. So now I can do kubectl get ingress. All right, so let's see what we have. All right, so if you look at what we have now, we have the address. So this is the database address. Sorry, I said database, pardon me, the load balancer's address. So this is the load balancer address. And of course, you can always go to your console to confirm things. If you come to the load balancer here, you will see that the load balancer has been created and it's still provisioning. Can you see that? Still in the provisioning state. And you can see here that it basically used the name of the group, all right, that we provided. So the name of the group. So if I click on this, still provisioning. And of course, you can see that all the redirects and everything is here. And you can see that it's also leveraging the certificate that we have provided already in the certificate, all right, manager. Okay. So like I said, the purpose of this video is just to show you how the EKS Auto Mode works, how Ingress works in EKS Auto Mode, how the storage, driver works in EKS Auto Mode, and all those kind of things, right? So it's not so much about the application that we want to deploy, but about what the EKS Auto Mode promises and what it offers. That is the purpose of this video, okay? So now if I want to test the Ingress, I can actually just go to my GoDaddy account and then just basically create a CNAME record or update the one I already tested with so that we can get this done. So I'll come here to my product, scroll down now. Okay, good. So here, I'm going to just change the load balancer endpoint. The name still remains the same. Save that. All right, so we can go to the SQL side of things, come here, and of course, update that as well. All right, so once that is updated, all right, so once we have that updated, I can actually come right here and just look at the load balancer and see if it is now in the ready state. All right, so now it is active. So which means if I do form.class of 25, you can see I'm here. And of course, if I do go to SQL class of 25, I can see that my phpMadmin, which is a platform I can use to manage my database, right? I can see that right here as well. Okay, so we've looked at how Ingress is being deployed now in the EKS Auto Mode. So there's no need for us to install the controller. Again, we basically just install the IngressClassParams component, the IngressClass component, and then for the storage driver as well, we don't need to bother too much about installing the controller and all. We just need to deploy the storage class, define the PVCs, and then mount it to application. And that's pretty much all that we need to do. All right. So I believe that with this explanation, now you understand what problem the EKS Auto Mode solves, how you can leverage it, how you can use it, and of course, how AWS has also taken over about 70% of the responsibility. And then now, all you need to worry about is your VPC infrastructure, your application, and all all of that. So you don't have to worry about the storage, the auto scaling, and all those kind of things, right? So that is one thing to note. And of course, if I want to delete all of these things that we've done, I basically would just do kubectl, delete -f, and then I'll say dot, and that will delete the storage class, delete the load balancer, delete everything for us, very, very quickly. And once that is done, of course, I can do my Terraform destroy, auto approve, and that will destroy everything that we have created just now. Okay, so I believe that with the explanation that I've given you today, you have come to an understanding of what EKS Auto Mode is, how you can deploy that through Terraform, and how you can deploy your Ingress controller and, your storage class as well. So thank you so much. Don't forget to like, share, and subscribe. Until I come away next time, bye for now.